Yeah, hello, Adit, am I audible? Hello, Adit, is it audible? Okay, good morning, Adit. Look, so we are done with the vector addition. Okay, so I'll just give you one problem, solve it, and then we'll move to the next one. Okay? You are given two forces having equal magnitude. Two forces having equal magnitude. This is a thing. Two forces are given an with equal magnitude acting at a certain point. Okay, acting at a point, and their resultant comes out equals to the resultant have magnitude equals to either of one. Okay? Calculate the angle between vectors. Calculate angle between force vectors. Yeah, hello. That some network issue was there. But changing now. I'll write the question again. Two vectors, same magnitude, acting at point, and resultant is of same magnitude. Same magnitude as of either one. As of either one. Calculate angle between them. Okay? It's a problem. Just let me solve it and let me know the answer first. Uh, got the answer for this one, Adrit? Aditya, have you calculated the angle between F1 and F2? Let me know first. If not, then let me know. I'll solve it and move to the next one. Giving you solution for this one. Look, very simple. You can see plus F1, F2 angle. Look, this comes out as 2 times of this. So you can simply say that. Fine. Okay. Condition for zero resultant. Okay. So the first condition is look. Um, One is the resultant of two vectors can only be zero if they're equal and opposite in magnitude. Okay. If two vectors are equal in magnitude but opposite direction, then they can be, then a resultant is zero. If you want, you can apply the formula which we are using. And another way, this analytical way, you can simply say that one vector is in pointing this direction, another vector is pointing to the opposite direction. Okay, so you can simply say that f1, this is f2, f1 plus f2 will come out as zero. Another thing is resultant of three or more vector comes out as zero. Already, although these all the things that we have already studied, resultant of three or more vectors is zero if they make a closed circle. If they make a closed cycle, okay, just like this thing. So you can simply say that this is f1, like all these vectors whose cycle resultant is zero. Okay. These are the two important things. The third is we have to study, that is Lami's theorem. Okay. Lami's theorem is very important. Lami's theorem. It says that if you have three vectors, on this Lami's theorem is only for the three vectors. Okay. If three vectors, if a resultant of three vectors is 0, then um, magnitude of a vector is directly proportional to angle between other two vectors. Okay, okay, two vectors. So what you can say that, assume I have this kind of figure. Okay, these are the three vectors. Okay, these are the three vectors. Let's say f1, f2, f3. And I'm saying the resultant is 0. Then you can simply say that if I say this is alpha, beta, and this is gamma, you can simply say f1 is directly proportional to sine alpha, f2 directly proportional to sine beta, and f3 is directly proportional to sine of gamma. Look, this is a vector. Okay, this is a vector. The magnitude of this vector should be proportional to the angle directly up in front of it. Okay, or you can say between these two vectors, between other two vectors. So you can say that if you remove this proportionality, you will come up with a new relation, that is f1 equals to k, some constant times of sine alpha, f2 equals to k times of sine of beta, f3 is equals to k times of sine of gamma, and this will result you can say that it is like f1 by sine alpha, f2 by sine beta, and f3 by sine of gamma. This is a relation, and these all things are equals to k. This kind of represent this can be represented in another way also. I'll just show you. It's not necessary that always the three vectors will be like this. The same can be represented in one more factor way. Let's go further and downside. Okay, so look, assume this is one vector. I'm keeping it for another vector, another vector. Okay. I want to show you where how we can represent it. So you can simply say that I have another representation for all these kind of different vectors. What is that? This was my A vector. Okay, let's put some naming for all this. This is A vector, this is B vector, and this is C vector. Okay. So this was my A vector. Um, this is my B vector. So this is my B vector. Put it like this. So this is B vector, and the last one is C vector. So you can simply say that this is my C vector. Somewhere here. C vector. That's it. You can see it is forming a closed circle. Okay. Now I said this F1, this A was nothing but F1 itself, right? So the magnitude of this is equals to the angle between B and C. What is the angle between B and C? If you see carefully, just extend it a little bit. This is B going, this is A going. So angle between them is this or this. Okay. Understood? So you can simply say this. We are looking for this particular angle. I hope it's clear a little bit. Okay. So the outer one is the angle, not the inner one. So alpha and beta, basically this is A, this is B, basically this is C. So this is the beta angle. Here it will be a beta angle in between. What is the angle between B and C? Where is that? This is B, this is C. Sorry, it should be alpha. Okay. And this extended little bit. What is the angle between A and B? In between A and B, you have gamma. So this is gamma. And here you will be having beta between A and C. Is that clear? This is how the another representation will look like. So I will give you another problem. Let me know the another representation. We are done with the Lami's theorem. Just solve one problem, and we will move to the next topic. Basically, a very small topic is that regular component of the vector, basically resolution of vector. After that, the final thing, that is product of the vector. Okay, multiplication. You can say the product of the vector. That is more than enough. Okay. So one problem to solve this one. A long page. So the problem is, we are given three vectors. Given A vector plus B vector plus C vector. The resultant comes out as 0. Okay, where two have, out of these three, two have same magnitude, same magnitude, and the third one has, and magnitude of third is either of it. Magnitude of third one is root 2 times. Okay, not just add. When it's times, you have to multiply times of either of magnitude, either of the magnitude. These are the given conditions you have. Find the angle between all these vectors. Okay, compute angle between vectors. Vectors. That's the problem. Let's solve this one. Let me the answer first. So take minutes, solve it, get me the answer. Adit, have you got the answer? Look, a hint is you have to try the Lami's theorem. Don't go with some other method. Just try the Lami's theorem. You'll get the answer. You have to calculate the angle between A, B, and C. Okay, like A and B, B and C. That's correct answer. Basically 90, 135, 135. That's correct answer. All right, so we can move to the next topic, that is rectangular component. We have two ways to calculate rectangular component. One is in 2D, one is in 3D. 3D, so I'll go through each of them. One by one. So the first is rectangular component in 2D. Okay, two dimension. What is it? It's basically, you can say that you are given one vector random and a random xy plane. Alright, let's make it in properly xy plane. This is x, this is y coordinate, this is x coordinate. Okay, y and x. So you can see that, let's say this is a vector space, so you will see it is a basically magnitude and some direction, right? So what is that direction if I ask you? So direction is nothing but this direction is something in I direction, something in y direction. Okay, we are not even sure right now. So let's make it like this. Assume this is angle theta. When I say the rectangular component is, you have to resolve it in between this and this, such that I can ignore this part and I can individually solve this and this. When I say the rectangular component, resolving should be done that one side should be at 90 degree as compared to other side. Okay? This is what the resolution is all about. Okay, so what is the projection you are seeing for this vector on this plane and on this one? So you can say that if I see from this side by putting my eye on this side, let's not this way. If I see it from this side on this axis, so only this much length I am going to see. Can I see that? Adit? Only this is the length which I am going to look for. I will the only this length is going to be visible. If you look it from this side, Let me know if you are clear with this small part of observation. And same if I just go with the another way, that is on the y, which thing is you are going to look at only this part. Like if you put mirror, or if you put this, if you see it from this side, you can only look at this much part. Okay. So this is what the resolution is. It is not the case that you can take the complete vector from here to here. No, only the part of vector which is only for this much, and when you go with this thing, only this much part. Okay, understood? This is what we have to do. So I can simply say that this is my angle of, this is theta. Okay, so I need to calculate now the horizontal and the vertical. Two things I am yet to calculate. Mean to say I need to calculate this vector and this vector. So I can say that now the a of x. What is the part of a in the x direction? You can simply say that. So I'll just go for the cos theta. If I just calculate cos theta, what we are going to get is, for this cos theta, I will get this base and the hypotenuse. So you can say that magnitude of the base I have to calculate, and the hypotenuse is nothing but 8 magnitude. So you can simply say that this length comes out as, a times of cos theta. Base divided by a, so your base comes out as a cos theta. Okay, you can say that this length is similar to this length, right? So I can simply say that if I took out the sine theta maybe, so I will be getting h, and this is h b. Okay. It is nothing but h divided by a. So again, it comes out as height. Okay, it is height, not hypotenuse. H is equals to 8 times the sine theta. You can say that this length comes out as a times of sine theta. So this is what all resolution is all about. A of sine theta. Now, if you have to solve some problem, you are good to go because you know each of the vector. The vertical vector is nothing but what is the magnitude in the vertical direction? That is a times of sine theta, and you know the direction. That is j cap. You can see here you don't know the direction properly, right? And this is a x direction. What is in the x direction? You can say that a times of sine cos theta times of I vector. Okay. Even if I ask you get me the resultant of these two vectors, if you see when you calculate the resultant, you are going get, when you get the resultant, it will be a square sine square theta, a square cos square theta, 2 a square. Angle between them, again this is given to us, that is 90 degree. Cos 90 comes out as 0. So you can simply say that a will be taken out as a constant. Sine square theta cos theta, this will result to 1. So you can say at the end of the day, you have got r is equals to a itself. Okay, from where you started, you have ended up here. Okay, it is not needed because you already know the thing. It's because we are not given our vectors in I and j form, so we can use this method. Okay. Is that clear? Others, let me know if you are clear with the resultant component in the 2 dimension. I'll move to the 3 dimension. Okay? If you're clear with this problem. Look, 3 dimension is also easy. Just I have to add up one more axis. Okay. Look, when you solve the problem based on this, you will get a more hands-on practice. Okay. 3D. So this thing you need to be careful. The reason is we can't visualize the 3D in a 2D plane or single board and all. So it's like the 2D is more of visualization game. I'll try my best to make you visualize this thing. Okay, assume it to be a 2D plane. I am saying you are having a vector v, which is written as 3i plus 4j plus 5k. I just want to show you how this vector will look like in 3D. It means that you have 3 meter of distance in x-axis. So I can say that something around this is my x-axis. Okay? This is the length in x direction, 3 meter. Fine. In y, I have 4. So I'll go and make a 4 meter in the y. So this is 4 meter in the y, little bit longer than the x. And there's a 5 in the k. So maybe I can make it this. So this is 5. Okay. I need to get a vector. So this vector I start from this point. I will say go to the extraction. Okay. Then it says I have for y direction also. So it will try to move up in the y direction towards 4. Move till here. Okay. This is in the 2D plane right now. You can say this is a 2D plane right now. 2D of xy. This is 2D of maybe what was that? Yeah, this is xz. Okay. So it will be xz of 2D. And this is a 2D of y and z. Okay. Z. That's all. After reaching this point, the vector will say, I still have one more thing length left, that is 5 in k. It means now my vector will start moving in the y with z direction. What is the z direction? This side. Somewhere here. Basically, this is the z. So if you just move it something like this, okay, I need to get it a little bit. Just this, try to move this thing. Seems good. It's fine actually. From here you can see this, and the last one is this thing. Mm, I think if I can extend it a little bit. So, all right. So you can see that this length represent 3 meter. This is in the 4 of y, and this is in the 5. So you can simply say that my this vector goes into the 3, followed 4th, then goes in with the 5. So you can see finally it came here. Okay. Mm, if I had more of length in the x-axis, let's increase the x-axis and decrease the y-axis. Okay. I'll just try to increase the x-axis. Make it 5. No, 7. Let's make it 7. Okay. It will be easier for us to visualize. So might this will be 7. This can go to as a 7. Again reach to the 7. Also reach to 7. This point is supposed to be at this particular. This point is supposed to be here. Now you can see this is my extraction, okay, y direction, and it come up to this z direction. Now it makes sense more of it. Let's go and increase the 7, 7. So this is 7. Now you can see that I have 7, okay. And what was the individual ones? If I just go and look at the individual ones, x and y only, so you can simply say that this was my x and y plane vector, okay. This was my y and z plane vector for 3, 4, and 5, and this was my this plane vector. Is that clear? So if you resolve this particular main, this is my v vector. Okay? If you resolve this v vector on the x and y plane, this is the vector you are going to get. Okay? This is the vector you are going to get. If you do it in the y axis, this y and z axis, this is the vector you are going to get. Basically, to get this, you have to see from the this side. Okay. To get to this one, you need to see from this side, and to get the bottom one, you have to look at from the top side. Okay. That is the thing. Then you can visualize all properly. Mm, it should be 3D options should have been there, but okay, no problem. Okay, can you visualize this image? When I say some angle, it means now this vector makes this angle, you can say x angle. Okay, this makes x angle with the x axis, or you can call it as alpha. Beta angle with the y axis, and gamma angle with the z axis. Okay, is that clear? All right. So if I ask you what is the cos of alpha, so you can simply say that alpha is this, right? What is the alpha? The total. This is hypotenuse, and what is the length for this one? So you can simply say that the length for this one is this much. Basically, the base for this one is this x-axis. So you can simply say that whatever the length in the x direction divided by the magnitude of theta. Okay, this is cos alpha. Similarly, cos beta you are going to get is y divided by basically length in the y, because you can see this is the thing. Okay, this is making a 90-degree with this. So v and cos gamma, finally you can say that. What is that cos gamma? Z divided by x. So you can, if you just calculate it, what you will get? X length is nothing but whatever the magnitude and angle made by that thing. Y is equals to v of cos gamma beta basically. And y is equals to, z is equals to v of cos of maybe gamma. Look, here you see I am taking all the resolutions in the x, cos and cos and cos. Here also you can get the cos and cos. How? If you say this is, if this you said this is theta, you can say this is phi. So this you can also write, instead of sine you can also write v u y is equals to v of a of cos phi. Okay. But the thing is, here what happens, only two things are there. Okay. So there is a relation for 90-degree minus this gives me phi. So when you do this, a of 90-degree minus phi, it will become this theta itself. Okay. So we don't need to have two vector, two different things here. Understood my point? But we can't do the same thing here. The reason is it's not very simple to do. It's like this is one point. This side you are going with the z axis. This side you are going with the y axis, and this side you are going with the x-axis. Okay, so here you can't have a direct relation because it's each of them are itself at 90-degree. Okay, so you can't directly get a relation between gamma minus this and this and whatever what you got. Okay, understood my point? Um, Others, let me know if you're clear with this thing. Yes, clear, right? Now I'll just go with one relation, a very simple relation. That is, you can simply say that cos square. Okay, one more thing. Okay, all right. One more thing. If you see, these are the different angles, right? I, J, K in the different directions, right? You can get this x vector, y vector, and this vector. So these are the things. Okay. Um, One more thing. If I ask you what is the resultant of all these vectors, you know the resultant will come out of this itself, right? How it comes out is if I calculate cos square alpha plus cos square beta plus cos square gamma, this the resultant is one. Okay, why the resultant is one? The reason behind this, you can put the values. What you are going to get x by v square plus y by v square plus z square by v square. Okay? This comes out as x square plus y square plus z square, okay, and whole divided by v square. Okay, let's go back to the figure. If you see, this is my v, right? This vector, I'm talking about this v vector. This is x square. If you do x square plus y square, what you are going to get? You are going to get this vector, okay, r vector. So can I say this thing will result in r square itself? And if you do r square plus this z square, this length, you are going to get this as a hypotenuse. So I can simply say that the resultant of this whole thing will result in v square. So that's why when you do this, you are going to get it 1 itself. Basically, this is same to this. So can I say this relation holds true? Let me know if you can understand the figure. Okay. For this, you just have to sit at least for 15 to 20 minutes, analyze the image by yourself. Okay, by increasing length of x, y, and whatever you can do. Okay, because it's more of analytical. Because in 2D we can visualize it properly, but in 3D it is not that easy. Okay. Now we are done with the resolution of vectors part. Now we can swiftly move to the main multiplication of the vector. Okay? When we talk about the multiplication of vector, we have two things to be care about. One is dot product. One is um, I'll go to the new page for this one. It would be better option. Can you see the new page? I am coming with this multiplication of vectors. Okay, multiplication of vectors. So what does this mean? Let's see. When I say I'm going into the multiplication vector, we have two methods to do. One is scalar, also known as dot product. The second is vector, which is known as cross product. Okay, so either words can be used. Most of the time, dot and cross will be used. The reason to use the reason to use the word scalar is the result of this kind of multiplication is a scalar, and here it is a vector. Why we use dot? Because representation, when you are multiplying it, the representation is this, and here the representation is cross. Why? If you are given a and b vector, so it is written as a dot b. Whenever you see there's a dot and b, it means you are going to do the dot product, and here the resultant is just r, only magnitude, scalar quantity. Okay, this won't result you this thing, dot. When in cross product, a cross b, you can see this is a cross. And what kind of result? Some resultant along with some direction. Okay, we call this as generally an unit vector direction. and you can finally write this is this a vector quantity. Okay, this is the thing. So I think as per the time we have, we can only discuss the dot product, and I will try to end the dot product by today's class still, so that in the next class we are only left with the vector product. Okay, so yeah, that's the thing. Let's move on to the scalar product. In case of dot product, what is dot product? Basically, it defines as the product of magnitude of two vector and the cosine of angle between them. Dot product is defined as cosine, okay, product of magnitude and cosine between them. Okay, product defined as product of direct magnitude and cosine between them. What does this mean? If I say you have given two vectors like this, this is one vector, okay, this is another vector, maybe like this. So you can simply say that a vector, b vector, theta. So a dot b is nothing but a magnitude multiply. Here you can simply do, because it's like 5 into 6 you have to do, so this will result to 30. Very simple scalar product you can do. This will result equals to cos theta. This is what the relation says. Is that clear? Okay, so this is what actually does this mean? It means that when it says the dot product, the idea to say this, you have to get the two vectors having a same direction, okay, and you have to do the scalar multiplication basically. But if you see here, these two vectors are not aligned with each other, right? When I do the dot product, I need two aligned vector with the same direction. But I don't know. There are two options. Okay, what you can do is I'll just tell you cos theta. In this case, if you see this A is going this direction, this B is going this direction, and I told you I need two vectors in the same direction. So what I will do, I will look for A's component. What is the part of A who is here? You know, each vector, if you want, you can resolve into multiple. Like we are just done with the rectangular component. If I say this is my one component, so you know another component must be perpendicular to this one, right? If this is in this direction, it will be in this direction, right? We have just studied that thing. So we have to just go with the proper angles and all. So if I say this is angle theta, so this part can be resolved in this side as little bit downside. I'll just make it a little bit downside. You know, if I have to resolve it in this side, on this axis for A, only this portion of A is visible, right? So I can simply say that this is the thing. And what is the value of this? We have already studied. If this is theta, so you can simply say that this is cos theta. Although I don't need this part, the perpendicular, but you can just write it because we need the same thing in the s- what is that vector product. So this is what A of sine theta. I don't actually need this. No need of in dot product. In dot product, now you can simply say that I have two aligned vector, that is vector B and this vector. What is the direction for both of them? Then same. Okay. So you can simply say that A dot B is nothing but B vector and the part of A. Basically, you can say the part of B vector and part of A vector, which they are in the same direction. Okay, that is A of cos theta. So you can simply say that this is magnitude. This should be magnitude. Okay. So yeah, that is the thing. Answer. Okay. Is that clear? You can do the vice versa also. What you can say that on this a axis, what is what is the portion of B? So you can say this is the portion of B I am going to see. Okay, so you can simply say that here B of cos theta and multiply both. Here you can simply say of a of cos theta multiply both. You can get the same result. Okay, it doesn't matter either way you do. Any doubt here? All right, no doubt, right? Let's move to the next. Okay, Adrit, I have some more discussion to be done at the last point. You know some coordinate axis part, right? Let's say this is my coordinate axis thing. So as per the coordinate axis, what happens is if you have this I, you know this is I, J, I, and K, right? So if I say, get me the dot product of A dot A. So you know what is A dot? Dot means the component of each vector, the basically the magnitude of each vector's component in the same direction. You can say the magnitude is one, right? And they have same directions. You can simply write as one into one comes out as basically one multiple. If it is scalar, so you can simply write as one. Okay, we don't even need the cos theta. When I need the cos theta, when I need some angle. Here you can see I don't have any angle. Okay, this is a formula which we have derived if they are not equal. So even if you apply here that cos 0 comes out as 1, doesn't make difference. Okay? So here you can simply say that A dot J. The magnitude which are aligning in the same direction. This J has a magnitude in this direction with 1. This also has a 1. So you can simply write them as 1 into 1, 1. K dot K is equals to 1 into 1 is equals to 1. Okay. If I ask you I cross J, so you will say either way the component of A, the component of J on this, you can simply say if you look at from the top, what is the component of J you are going to look at this axis, you only this particular point means your length is 0, so you can simply say that 1 into 0, or either way 0 into 1. Okay, because you have two options, either take this A's component and this, or this component and this. Same you can do for this and this. Okay, these are some ways you can do. So this is I into J, J into K, I into K. 0, 0 by a two way. I 1 into 0 and 0 into 1. 1 into 0 and 0 into 1. Let me know if you're clear with the concept, not with the formula. Okay. Formula is fine. It's an easy, you can do it by yourself also. Okay. So one more last thing to be done with this part. You have two vectors A, which is written as A1 ax, basically x component, that is I, plus ay in j component, plus az in k component. Another is b vector. What is that? A of x. No, you can write this as b of x in I cap plus b of y in j cap plus b of z in. So what is a dot b? Very simple idea. Just go with it. Axi plus ayj plus azk dot product b x. Whatever we used to do in a simple multiplication in earlier cases, the same we have to do here also. Okay, what we used to do in kind of multiplication, we take this, okay, we multiply this with each of them. Okay, so when you do this, you can expand it by yourself. Okay, for each axi, you will be having bxi, byji, byj, and byk. If you see carefully, you will in each cases you will be getting some magnitude this part, some magnitude maybe bx, by, and some. Okay, so what you will see when you get I and I into I will become 1. So here you can see you are left with bx. But the moment you get ax, by, here what will happen? I into j. You know I into j comes out 0 as a dot product. So this will become 0. Here you will be having bz into a. Again I into k will be 0. So you can see only I into I part is left as 1. So the same for each of them. You will be getting ay and by will be left. Here you will be having only the bz and az left. Okay, j into j, k dot k, basically dot you have to use, not the. So this will get 0, this will get 0, 0, 0, 0. Okay. Addition is there in each case, so all you can see what you are left with. Final dot product will be, if you want, you can expand it. Okay. We don't have time, so I won't expand it much. Bx plus ayby plus az bz. So you can simply say that if you see any kind of multiplication, just multiply I with I, j with j, and k with k. Just like we used to do in multiplication, subtraction, and addition, where we subtract I with I term, j with j term, and k with k term. Okay, is that clear? All right. So some relation. Okay, we are done with the today's class. Okay, I will explain the rest of the final. What is that? Vector product and some more properties of scalar one in the next class. Okay. So by this, I'm ending the session. Any doubt, you can let me know. I'll clear it the next class itself. If no doubt, you can just make an exit. Okay. All right. I feel no doubt, so I'll end the session by now.